All right, welcome back to lesson 105 for geometry. Oh yeah. So I definitely know what we just did because as I told you, I literally recorded back to back to back. And so the first two are actually way shorter. I think that this one is going to be probably the duration of both the first video and the second video. So this one's going to be a little bit longer because we're going to get to multiplication, and multiplication of matrices is way different than what we did before, because before we only multiplied one number by a matrix. That was lesson 102, and in lesson 100 we didn't even multiply, we just added. You could subtract too, it doesn't matter, it's the same principle. But today we're going to do something which is multiplication, and you have to know how to multiply because just like in fractions, there is no real division. The division of matrix is actually a little bit more complicated than that. And so obviously, what would math be if it was easy, right? I would probably not have this booming YouTube channel in which, I have so many followers. Hopefully by now I have over 30, but that is a stretch, asking for 4 subscribers in over a week and a half. Crazy, I know. But if I did, maybe that Braid Shadow Legends sponsorship is in the works. So I won't know because obviously I'm recording this the week before, so I have no idea. But let's get into lesson 105, which is rotation and reflections in the coordinate plane. And I know that this title doesn't say anything about matrices, but this is the very important lesson of matrices. Now, I think that this is not perhaps hard, it's just a lot of work and you have to pay attention. But at the end of the day, it's about multiplication. So hopefully if you know how to multiply, you will do well. If you don't know how to multiply, that's a different story altogether. So let's actually get started. Okay, so in here we're going to start multiplying, but you'll see that this is a 3 by 2 matrix and this is a 2 by 3. And so most of you are going to be like, wait, how can we do that? Because when we added, it had to be a 3 by 2 added by a 3 by 2. Well, when we multiply, it's different. What we need to do is understand that the column of the first matrix and the rows of the second matrix have to match up. For us to be able to multiply two matrices, we need to understand the columns of the first one and the rows of the second one have to match up. Because it's 2 times 2, I am going to be able to do it. What is going to be my answer? Well, the answer is going to be a little bit long, so I'm going to get to that in a little bit. But the most important thing is that I have to know that my resultant matrix, and I'm going to write it right here so that then I can fill it out. I'm going to try to do all the work here to fill this one out here, is going to be a 3 by 3 matrix. Okay, so my resultant matrix of multiplying this 3 by 2 matrix and this 2 by 3 matrix is going to be a 3 by 3 matrix. This is why I told you that this is going to be different than addition and subtraction. So that's why I put that, because obviously 3 by 3 is going to be more of a square than a rectangle. So having said that, I'm going to erase this, and I'm also going to make sure I'm recording because I don't want to just be talking to the wall again. Yay, success, I'm not talking to the wall. So now what we're going to do is I'm going to write a huge matrix in which I'm going to show you what I'm going to do. So the first step is I'm going to grab my first row and multiply it by the column in the second matrix. All right. So I'm going to multiply the first row by the first column. But there's also an order here. So what you have to do is you have to multiply 5 times 0, right? And -2 times 4. Not times -3, but times 4. -2 times 4. And in between these, you can actually just put them like this. I think I'm going to put parentheses. I think it's going to be better. And in between these, what we're going to do is we're going to add. Am I going to add? Yes, I'm going to add. I knew I was right. So I'm going to add. Okay, so I'm going to add that. So that's going to be my first term. My first term is going to be 5 times 0 plus negative 2 times 4. Because 5 times 0 is 0 and negative 2 times 4 is negative 8. My first term is going to be negative 8. That's why I wanted to leave that one there so that you understand that my work is here, but my answer is here. Okay, so that's going to be my first one. For my second one right here, I'm going to multiply my first row by my second column. And again, it's going to be this element, 5 times negative 3. So it's going to be 5 times negative 3 plus, always plus, add negative 2 times 0. Negative 2 times 0. Because negative 2 times 0 is 0 and 5 times negative 3 is 15, my second term right here is going to be negative 15. You have to be very careful. We're going to always go by rows, okay? So we're going to go by rows. And then my third one is going to be, my third element in my first row is going to be 5 times negative 2 times 2. So 5 times, sorry, not by 2, but by 2 and 4 because it's a column. So 5 times 2 plus negative 2 times 4. Well, in here we have to be careful and do 5 times 2 is 10. Negative 2 times 4 is negative 8. 10 minus 8 is going to be 2. Okay, so that's going to be my first row. Negative 8, negative 15, and 2. And then I have to repeat my process that I did for my first row with my second row. Now, I love it when I see a 0 because the 0 means that all the first ones are going to be 0, right? It just cool. 0 times 0 is 0, and then plus 2 times 4, which hopefully you know it's going to be 8, positive 8. Then I'm going to do by the second column, the second row by the second column. So it's going to be 0 times negative 3 plus 2 times 0. Whoa, look at that. This one is the hardest one. 0 times negative 3 and 2 times 0 obviously is going to be 0. Wow, crazy. And then again, second row by third column of the second matrix. And so it's going to be 0 times 2 and then plus 2 times 4. Well, what do you know? It's still going to be 8. Okay? So, oh, terrible. Oh my goodness. Rows. Okay, 8. So that's going to be that. Okay? So I told you, it's not a hard process, but it's a little bit intricate in that what you have to do, you can't forget what you have to do. And yes, there is a way to do it in your calculator, but no, I'm not going to teach you it. Anna is going to teach you it next year. I'm not going to teach you how to do it in your calculator. Please don't ask your siblings. For those of you who are in 12th grade, I'm pretty sure your siblings... No, it's actually pretty easy. They probably could now. But please don't ask them because I want you to learn how to do it by hand. If I have to do it by hand, you have to do it by hand. So the last row is going to be the last row of the first matrix by the first column of the second matrix. So 3 times 0, again, it's going to be, that part is going to be 0, but the first element is not going to be 0 because 1 times 4 is 4. So the element in the last row, the first element in the last row, first column is going to be 4. Then I have 3 times negative 3 plus 1 times 0. 3 times negative 3 is going to be negative 9 because 1 times 0 is 0. Pretty easy. And then finally, we're going to have 3 times 2. And I know it's not quite there. 3 times 2 plus 1 times 4. 3 times 2 is 6. 1 times 4 is 4. 6 plus 4 is 10. Look at that. I got -8, -15, 2, 8, 0, 8, 4, -9, 10. Let me check if that's correct. -8, -15, 2, 8, 0, 8, 4, -9, 10. Oh, look at that. I am correct. And so that's how you actually do the multiplication of 2 matrices. That's example 1. I realized that you couldn't see the top number over there, the 2. So this is just a quick screen to show you what my resultant matrix was. -8, -15, 2, 8, 0, 8, 4, -9, 10. All right, before I move on to example 2, I didn't realize it's only 3 examples, but the problem is the multiplication makes it a little bit longer. But these are called reflection matrices. So what happens is that if you want to reflect anything on a coordinate plane, you can actually use this matrix, the x-axis, for the x-axis. If you want to reflect anything up on the x-axis, it doesn't matter, because the thing is that I told you, you remember how I told you that this is going to be a 2 by 2 matrix, right? And so a point matrix is going to start with a 2, because you can only have the x and y. And so because you can only have x and y for a reflection matrix, you can actually reflect anything that is actually graphed in a 2-dimensional graph. So that is why this works always to be able to reflect upon the x-axis, and this works always to be able to reflect upon the y-axis. Now you will look at them, right, and see that the 1 and the -1 are switched, but that's literally all it takes for you to be able to reflect graphs on the x or y axis with these 2 matrices. This is why matrices are kind of important for geometry, but actually matrices, I was going to say matrices, never say that, okay? Please, Lydia. All right, so matrices are going to be really important for something called linear algebra, which is after multivariable calculus with differential equations. So if you get to that point in math, you will see what I mean. If not, then you won't see what I mean. And to be honest, I don't even know what I'm really talking about, because the highest math I ever got to was calculus 2, and multivariable calculus with differential equations is considered to be calculus 3. So I never really took that. But, so you know that this is a reflection matrix, 1, 0, 0, -1, and this one, -1, 0, 0, 1. This one's for the x-axis, this one's for the y-axis. Now let's get into example number 2. All right, example 2. So we have a triangle JKL, that is going to be reflected upon the x-axis, because I told you that you had to know the x-axis matrix. And I mean, you can go back in the video or look in your book. I mean, easy peasy either way. It's going to be 1, 0, 0, -1. That is going to be the reflection matrix over the x-axis, right? And so we have the points there that are -3, 4, 2, 4, 2, 1. So because this is a 2 by 2 matrix, you can actually multiply before or after, but, because what we're going to do, I'm not just saying but a lot, okay? That's not what I'm trying to say here. I'm sorry. I apologize. What I was trying to say is this. You have to be really careful about how you do the transformation here. So what we're going to do is we're going to multiply first. So the first thing is we're going to have the reflection matrix first, and then we're going to have our point matrix. Our point matrix is going to be -3, 4, 2, 4, and 2, 1. JKL. So that is, great triangle JK, because that's literally what I was doing. JK, just kidding. I wasn't really saying that word rear end a bunch. Okay, so we have 2 times 2 and 2 times 3, right? And so what we know is that the resultant matrix, and I'm going to put it a little bit lower, see if I can actually, you guys can see it over here, is going to be 2 by 3. So this is going to be a 2 by 3. Maybe I made it too long. It should be a little bit shorter. It's going to be 2 by 3. Okay, so again, I'm going to show you the whole process again, just because it's a new thing that we're doing, and I like to torture myself. So we're going to start with the first row and the first column. It's going to be 1, 3, plus 0, 4, 0 times 4. So 1 times negative 3, sorry, 1 times negative 3, got myself there. 1 times negative 3 is going to be negative 3, plus 0, 4 is just going to be negative 3. So my x point is still going to be negative 3. Now for my next point, right? Not next point, but next x coordinate. It's going to be 2 times 1. And hopefully by now you see a little bit of a pattern that's going to develop. 4 times 0. 2 times 1 is 2, plus 4 is 4 times 0 is 2, because 2 times 1 is 2, plus 0 is 2. Now, I'm going to just guess what my next point is before I do it. I think this is going to be a 2. And I'll show you why. Because 1 times 2 is going to be 2 plus 0 times 4. 0 times 1, I mean. This one, I'm in the last column. It's going to be 1 times 2. It's 2 plus 0, 2. So did you see that? The x values stayed the same. Now, what happens to the y values? Okay, so what's going to happen to the y values? I'm going to, again, make a theory, but it's going to be the opposite of what they were. So instead of being a 4, it's going to be negative 4. Instead of being 4, negative 4. Instead of 1, it's going to be negative 1. But the only way to actually do it, or check, is to actually do it. So now we're going to multiply the second row. 0 times negative 3 plus 4 times negative 1. Oh, look at that. 0 times negative 3 is going to be 0. 4 times negative 1 is going to be negative 4. So it's going to be negative 4, negative 4, negative 1. Please don't be lazy like that. I'm going to still do it. I just know that the answer is going to be that, but I'm just going to keep on doing it. So it's going to be 0 times 2 plus negative 1 times 4, which is going to be negative 4. And then finally, I got 0 times 2 and negative 1 times plus negative 1 times 1, which is going to give me the resultant matrix of negative 3, 2, 2, negative 4, negative 4, negative 1. But the points are negative 3, negative 4, 2, negative 4, 2, negative 1. And that would be triangle JKL reflected upon the x-axis. All right, welcome back to the last example. The last example is going to be a 270-degree rotation of this quadrilateral. Now, understand something. There's going to be 90, 180, 270, and 360 rotation. The 360 rotation, I mean, if you have to know that one, it literally means that it starts at the same place where, it ends at the same place it starts. So what we're going to do is we're going to use this transformation matrix, which is the 270-degree rotation matrix. If you don't know where that is, that's on page 682 in your book. And so, as I told you, you always have to start with the transformation matrix first, and it's going to be a 2 by 2. And the reason I write it here is so that we understand what we're going to do, because we need to also know what our resultant matrix is going to look like. And it's going to be a 2 by 2 by a 2 by 4. Because these two numbers are the same, my resultant matrix is going to be 2 by 4. Yay. And so my multiplication matrix is going to be negative 1, 3, 5, 3, 4, 1, negative 2, 1. Yay! So, again, I'm going to do all my work here in the middle. And I'm going to write my resultant matrix somewhere around here. 2 by 4. Okay? So, it's going to be first row by first column. 0, negative 1. 0 times negative 1 is going to be 0. And then I'm going to write everything down, even though I know some of you already know how to do it, but you have to, I'm just going to be thorough, okay? That's how we have to do it. So 0 times negative 1 plus 3 times 1. So 3 times 1 is going to be 3. 3. Yes, my first point is 3. Pay attention though, because we rotate it, it's not going to be the same numbers here as it was in the previous example, okay? Now we're going to do the first row by the second column to get my second element of the matrix. And so it's going to be 0 times 5 plus 1 times 3. Look at that. I got another 3. You see, I told you it was not going to be the same. Okay? I'm just checking that I'm going right. Yes. Because I would hate to do all this work and then show that I'm wrong. Because, you know, everybody makes mistakes, as we've learned before. But I make less mistakes than you do. Just deal with it. So we have 0 and 1 and 4 and 1, right? And so it's 0 times 4 plus 1 times 1, which is 1. Crazy. And then finally, we're going to do 0 times negative 2 plus 1 times 1. And it is going to be 1. Right? So now I'm done with all my x values in my resultant matrix, in my answer. Now I have to go into the second row, first column. So negative 1 times negative 1 is going to be 1 plus, well, I don't know what's going on there, plus 0 times 3. Right? And then 5 times negative 1, or negative 1 times 5, sorry, plus 0 times 3. Right? For that one, I was doing this right here, the second row. So in here, I got a negative 1, which I forgot to write here for the first term of the second row, first term of the second row. For my second term in my second row, I'm going to get negative 1 times 5, which is going to be negative 5. Well, look at that. Now, I'm going to do negative 1 times 4. I don't know what this is. Probably tired. Recording this videos back to back to back is a little bit taxing. And 0 times 1. So it's going to be negative 4. And finally, for the last element of the last example I have to go over for geometry in this 2 weeks is going to be negative 1 times 1 plus 0 times 1. Wait, hold up. It's negative 1 times 2. You see, that's why it's important to do it and not just think it. All right, so it's going to be negative 1 times 2 plus 0 times 1, which is going to be negative 1 times negative 2. Again, I told you I'm tired, but, you know, I didn't make a huge mistake in which I couldn't correct myself. And so I got 3, 3, 1, 1, -1, -5, -4, 2. But my points are 3, -1, 3, -5, 1, -4, 1, and 2. Let's check. I got 3, 1. Why did I get -1? You see, that's why it's important to check. -1 and -1 is going to be +1. You see, nobody told me. Thanks, guys. You know, make me look like a fool online. And then we have 3, -5. That's correct. And 1, -4, and 1, 2. So the only element I had gotten wrong was the first element of the second, the first element of the second row, but that's pretty much it. So understand that for multiplying, it is a little bit of a long process, but it's pretty easy because it's multiplying and adding, multiplying and adding, multiplying and adding. And the order is row, column, row, second column, row, so first row, first column, first row, second column, first row, third column, first row, fourth column. And then for the second row answers would be second row, first column, second row, second column, second row, third column, second row, fourth column. I know it could be a little bit overwhelming at first, but as you start practicing, it's going to get easier to do. And yeah, that's it. So this will be the last lesson I'm going to record for the geometry. It has been, what a ride. What a ride that we've actually gone through together, you know, ups and downs, mostly downs, not really any ups. Maybe the only ups is Promitos Heights. And that's it. Yeah. So I'll guess I might see you in the next one. Hopefully I will see you in school, but it doesn't seem very likely. So, yeah. Have a good one.